So I've shown this before, but I want to. It's at the end of like an hour-long video that talks about a whole bunch of other crap. And there's just, I think there's only one example of it. Even I don't have time to look through all that bullshit. So, yeah, I thought I would redo this just as a standalone thing. Hopefully shorter, maybe 7 minutes or something. Who knows? Yeah. So when we're kids, we're taught things like 1 plus 1 is 2. This can be true, but there is an assumption being made. There's an axiom being applied here. And an axiom, in this sense, is basically an assumption that you're sort of not allowed to change. You're not allowed to recognize that it's an assumption. You're not allowed to manipulate it. You're just kind of forced to go along with it. Right? That's generally what an axiom is. And so here there's an axiom that all of the numbers in your little equation here have the same unit. And if that's the case, then yes, 1 plus 1 is 2. And 15 plus 7 is 22, and, whatever. Your basic arithmetic operates the way you were taught that it does. But if we remove that axiom, which there's no reason that we should hold this specific axiom, because it has nothing to do with the claim that 1 plus 1 is 2, if we abandon that axiom, then it falls on its face, and 1 plus 1 can be absolutely anything. So a simple example, let's just say, let's make 1 plus 1 be, I don't know, 7. Feels like nonsense. Hello. Focus. There we go. Feels like nonsense seeing that, I'm sure. 1 plus 1 is 7? What? Well, using just regular numbers, we can make this work. I can demonstrate this. Right? So if I turn these into fractions, right? The numerator of a fraction is the number of things that you have, and the denominator of the fraction is the kind of thing that you have, or the unit. So the only trick I have to do here is I have to give these all different units so that it works out. And the way that you add fractions, you're going to have to multiply both denominators by the opposite numerator and add them together under the axiom that the units are now the same. Right? So since these are ones, I just need two denominators that add up to 7. And then for the denominator, we just multiply them together. Right? So say I grab like 5 and 2. So 1/5 plus 1/2 should be 7 somethings. How about tenths? So if we convert this into decimal, this is going to be 0.5, this is going to be 0.2, and this is going to be 0.7. 0.2 and 0.5 is 0.7. Hey! When we come back to our world where we use the axiom that the units are commensurate, it does work. This is true. Right? Let's do something even more fun. Let's see if we can get something like this. So 1 plus 1 is negative pi. Huh, well, okay. How about I did this one in my head earlier, so let's see, it might not work. I think that'll work, but I did it in my head, so I only kind of trust myself. Alright, so the numerator is going to be pi plus 1 minus pi So that's wrong. Yeah, I jacked that up. So let's, instead of playing the game where I think I know the answer, let's figure out what this actually is. Okay, so pi plus 1 minus pi, that's going to be a 1 minus 2 pi. No, what am I doing? It's going to be 1. It's going to be 1. The numerator is going to be 1. Let's go with that. Okay, now our denominator is pi minus pi squared. So it's still something crazy, and I don't know what the hell happened in my head earlier. Sometimes I'm stupid. Yeah, and then you could do whatever. So it turns into some fun adventures. Anyway, yeah, it could be anything, right? And we can see in like an ordinary mundane situation that we can get 1 plus 1 is, let's say, let's make it 12. Let's make it 12. Why not? So this is going to be 1 boar, like a pig, and this is going to be 1 spider, and this is going to be 12 legs. Hey, look at that. When our units are different, then we can get 1 and 1 adding together to give us anything. Here, our units are different. It's 5, or it's a fifth, it's a half, and it's a tenth, and I got 1 and 1 being 7. Here is just craziness. I got 1 and 1 to be 1, apparently, which I didn't expect because I can't do mental math, apparently. I don't even know what in the world I did. Yeah, so 1 plus 1 is not 2. Unless you make certain assumptions.